Hello everyone, I am Jillian Kakachan.
And I'm Julia Chilo. For today's video, we will do a video tutorial presenting by Julia Chua and Jillian Kakachan. So, let us first talk about kinematics.
Kinematics is the branch of mechanics that deals with the motion of objects without reference to the forces that cause them to move.
So, the second one is, what is the difference between distance and displacement? So, distance has scalar and magnitude and total path covered, and it can be positive. And the fourth one is meter and kilometer and feet. In displacement, it can be vector and magnitude direction. And the second one is the shortest distance between initial to the final position. And it can be positive, negative, or either zero. So, scalar quantity, it tells us how much an object has covered. Note that scalar quantities only have magnitude.
While vector quantity, it only has magnitude and direction. The difference of scalar and vector quantities. As you can see in the left picture, speed is considered as scalar, while in the right picture, it says that velocity is vector, which means direction is also included.
So, calculating for the average speed. Average speed is the distance traveled by any moving object per unit time.
Now let us try to answer a question about in solving average speed. What is the average speed of a bicycle that travels 20 meters in 15 minutes? The given is distance 20 meters and the time is 15 minutes. And the formula is speed equals total distance over time. Solution. Average speed equals 20 meters divided by 15 minutes, and your final answer will be 1.33 meters per minute. And now let us try to solve for the average velocity. Find the average velocity of a vehicle that is traveling at 120 kilometers east in 2 hours. Given, the distance is 120 kilometers east and the time is 2 hours. And the formula is speed equals total distance over time and east. Solution. Average velocity equals 120 kilometers east divided by 2 hours. And your final answer will be 60 kilometers per hour east.
So, acceleration. Acceleration exists when velocity changes. Example number 1. A car travels in a constant speed for 80 kilometers per hour. So, letter A, acceleration exists, or letter B, acceleration does not exist. So, the correct answer is letter B. Acceleration does not exist. And now, let us head into the position versus time graph. This is the example of the position versus time.
Object started moving in 3 meters. Then its speed increased to 7 meters. Then that object continued to move in 7 meters in constant speed for 3 seconds. Then that object went down to 0 meters. Now let us try to find the slope, velocity, direction, and the kind of speed it has. Now let us say that this object is letter A. Then this slope is letter B. Then this line or slope is letter C. Now, letter A. Letter A slope could be considered positive since this line is moving to the right. Then the velocity. This is our velocity. So it's positive. Direction. The velocity is positive, so the direction will be positive as well. And this slope is considered constant speed. Now let us move on to letter B. This slope could be considered 0, as well as the velocity, the direction, and this is constant speed. Letter C. The slope of letter C is negative since it's slowing down. Then the velocity is positive since here we only have positive velocities, and the direction is negative since it is slowing down, and this speed is considered constant. So we all know that slope is rise over run, as well as change in y and change in x, and it could also be meter over seconds, and this is also considered as velocity. So the slope is also the velocity. Let us look into a graph that is about velocity and acceleration. So as you can see here, the object started at 0 meters and its velocity increased to 8 meters. Then the object continued to move in a constant speed in 8 meters for 5 seconds. Then from 8 meters, its velocity decreased and went to 4 meters. And from 4 meters, the object moved in a constant speed for 3 seconds. Now, let us try to look in the acceleration. In letter A, the acceleration is positive, as well as the velocity, and its slope is speeding up. In letter B, you can say that its acceleration, it has 0 acceleration, and the velocity is positive, and it is constant speed. In letter C, its acceleration is negative, its velocity is positive, and it is slowing down. In letter D, you can see that there is no acceleration, and its velocity is positive, and it is constant speed.
In solving the displacement, you are going to refer to the corresponding area of the shapes in the graph. So in this graph, in number 1, you will see the shape of the triangle. So you will use the formula of number 1. So you will use the formula of BH divided by 2. Okay, so B is known as the base and H known as height. So the base of number 1 is 2. So yeah, and then the height is, here's the height, it is 8. So, divided by the 2. So, if you will divide all of this, and we'll get 8 meter. So, and number 2, you will see this, number 2, that shape is rectangle. So, you will use the formula of the rectangle, length times width. So, number 2, the length is 8. So, this is the length. So, 8. The times the width. So, the width is here. 5. It's 5. So, you will multiply. It will become 40 meters. So, in number 3, here's the number 3. So, number 3, it is triangle. So, you will use like in a number 1, the BH over 2, and the base is the here. So, it is 4 times the height. It's 1, and over 2 you will divide, and you will get 2 meter. So in number 4, like what we do in number 2, you will use that, the formula. So length times width, and you will get this. This is a rectangle. So see, it is, the length is 4. So the width is 3. So 1, 2, 3. So it's 3. And then you will multiply them. Okay, it will be 12 meter. So you will solve this. You will add all of this one. So you will look at the displacement. So if you're done adding them like this, so this called the delta x. So we'll solve that. 40 plus 12 plus 8 plus 2. And so you will use that meter, and if you done adding them, we will get 62 meter. And this is the displacement. Thank you.